Welcome to the session on resultant moments. The objectives for this session are to calculate the turning effect of a set of forces applied to a rigid body. The sum of moments acting on a body is called the resultant momentum. Recall that the moment of a force F about the point P equals mod F times d, where d is the perpendicular distance from the point P to the force F. Let's take a look at an example. Consider the diagram shown on your screen, showing the forces acting on a light rod. Calculate the resultant moment about the point P. Let's consider each of the forces one at a time. So, beginning with the 5 Newton force, we have that the moment of 5 Newton force equals 5 newtons times 2 meters, which is the distance of the force, or the perpendicular distance of the force, from the point P. And this equals 10 Newton meters, acting clockwise. Now let's consider the 9 Newton force. The moment of the 9 Newton force about the point P equals 9 newtons times 2 meters, which is the perpendicular distance of the force from the point P. And this equals 18 Newton meters, acting clockwise. Now let's consider the 7 Newton force about the point P. The moment of the 7 Newton force about the point P equals 7 newtons times 2 plus 4 meters, which is the perpendicular distance of the force from the point P, and this equals 7 newtons times 6 meters. Which equals 42 Newton meters. And this acts anti-clockwise. Here's a summary of our results. If we take the clockwise direction to be positive, we have that the resultant force is equal to 10 Newton meters plus 18 Newton meters minus 42 Newton meters, because this force is acting anti-clockwise. Therefore, the resultant force equals minus 14 Newton meters. In other words, minus 14 Newton meters clockwise, or 14 Newton meters anti-clockwise. Recall that when the distance is not perpendicular, as shown in the diagram, we are required to find the perpendicular distance. And this distance is equal to d sine theta. Recall that the moment of F about the point P equals mod F times d sine theta. Let's now apply this formula and the concept of resultant momentum to the next example. Consider the diagram shown on your screen, showing the forces acting on a light rod. Calculate the resultant moment about the point P. First, let's begin by calculating the perpendicular distances. Here we have that the perpendicular distance is equal to 4 sine 60 degrees. So here's the scenario for the 3 Newton force. Now let's consider the 8 Newton force. The perpendicular distance equals 4, in other words 1 meter plus 3 meters in this scenario, times sine 52 degrees. And here's the situation for the 8 Newton force. Now let's calculate the moments for each of the forces. The moment of the 8 Newton force equals 8 times 4 sine 52 degrees, which equals 25.216 Newton meters clockwise. Now for the 3 Newton force. The moment of the 3 Newton force about the point P equals 3 times 4 sine 60 degrees, which equals 10.392 Newton meters anti-clockwise. And finally, let's calculate the moment of the 11 Newton force about the point P. This equals 11 times 3, which equals 33 Newton meters anti-clockwise. Now let's calculate the resultant force. Taking clockwise as being positive, we have that the resultant force is equal to 25.216 Newton meters minus 10.392 Newton meters, because the 3 Newton force is acting anti-clockwise, minus 33 Newton meters, because the 11 Newton force is also acting anti-clockwise, and therefore it's also negative. Therefore, we have that the resultant force is equal to minus 18.2 Newton meters clockwise, or 18.2 Newton meters anti-clockwise. Let's now take a look at another example. Two forces acting on a lamina are shown in the diagram. Find the moment of each of the forces about the point P. Recall that a 2D object whose thickness can be ignored is a lamina. Let's begin by calculating the perpendicular distance from the point P for the 8 Newton force. This is equal to 7 sine 45 degrees. Now let's find the perpendicular distance from the point P for the 5 Newton force. This is equal to 7 sine 34 degrees as shown. So now let's solve example 3. The moment of the 8 Newton force equals 8 times 7 sine 45 degrees, which is equal to 39.598 Newton meters, acting clockwise. The moment of the 5 Newton force about the point P equals 5 times 7 sine 34 degrees, which equals 19.572 Newton meters, anti-clockwise. Therefore, taking the clockwise direction to be positive, we have that the resultant force equals 39.598 Newton meters minus 19.572 Newton meters, giving us that the resultant force equals 20.03 Newton meters to 2 decimal places. Acting clockwise. This brings us to the end of this session. If you have understood its contents, you should be able to calculate the turning effect of a set of forces applied to a rigid body. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.